Differentiation of trig functions. We've already looked at differentiating sine and cos, and just as a reminder, angles have to be in radians when differentiating trig functions. So a simple example, if we differentiate sine, we get cos, but with this we're limited to just an angle, which is x. It's far more useful to be able to differentiate when we have any function of x for the angle. So we get more useful formulae for differentiating sine and for differentiating cosine. The derivatives for these four trig functions are in the formula book, like so, but these are also limited because they're using the angle as kx, which is a linear function for an angle, like one of these. If your angle is non-linear, then these are of limited use. Now, better formulae to memorize start off with what we have in the formula book. So we take the angle, the linear angle, replace that with f of x, which could be any function of x, any angle whatsoever, and then replace the k with f dash x. So now our angle can be absolutely anything, any function of x. If we apply the changes to what you have in the formula book, so all of these highlighted terms in yellow are the angles, so kx has to be replaced with f of x, and the coefficients k have to be replaced with f dash x, like this. So you don't really need to memorize any of this, just look at the changes, replace kx and k with f of x and f dash x, and you can continue using the formulae in the formula book. Example 1, differentiating tan x. Tan can be written as sine over cos, so we can use the quotient rule for differentiation. So u is sine x, v is cos x, differentiate sine, differentiate cos, and then cross multiply. In the quotient rule you multiply these first and then these. That's always a minus, over v squared. V is cos x, so over cos squared x. The numerator is cos squared plus sine squared, which gives 1, and 1 over cos squared is secant squared x. So if you differentiate tan, you get secant squared x. And you should know the proof for differentiating tan, exactly as you see it here. Example 2, differentiating cosec x. Now cosec is 1 over sine, and if we use the quotient rule again, differentiating the constant will give 0, differentiating sine gives cos, cross multiply in this direction, then in this direction, and we have this, simplifying, gives these terms. All I've done here is the sine squared x, I've split that up as sine x times sine x. So in the numerator you've got minus 1 times cos x, there it is. In the denominator you've got sine x times sine x, which is sine squared x. And then simplifying, 1 over sine is cosec, and cos over sine is cot. Example 3, differentiating x times tan 2x. So we have a product of two functions of x. So we've got x and tan 2x. So using the product rule, so differentiating, and when you differentiate tan you get secant squared, same angle, but then you differentiate the angle as well. Differentiating 2x will give you 2. And then cross multiply and add. Again, to differentiate trig functions we use radians. Example 4, differentiating tan x to the power of 4. So if we imagine it like this, then what we have is a function in brackets raised to a power, and we can use one of the results of the chain rule to do this. So the power comes to the front, so the bit in the brackets there, copy that again, the power comes to the front, reduce the power by 1, and then if you differentiate the function that's inside the brackets, the tan x, we get secant squared x, and these are all multiplied together, so we get this. For practice, try these questions.